All right, kids, I have a somewhat of a shorter lesson today. It's only actually we're only doing 3 problems, but the third problem we're definitely going to spend a lot of time on. First two are openers. This is stuff that we were doing. It's not vertex form, it's standard form. I don't want you to forget about that. And we're gonna go ahead and graph. We're gonna find all the important stuff. You know, here, what can we do right away? We can tell that this thing's going to open. Whoops. This is going to open down because the a value is -2. We know the y-intercept is 0, 7. And that's really what we know right away, right? Okay. Now we're going to determine the vertex. X equals the opposite b over 2 times a. Well, -8 over -4 is +2. Now remember, that's just the x value. If I plug that in here, don't forget, you have to do PEMDAS. 2 squared is 4, and 4 times -2 is -8. So -8 plus 16, that would be +8, and that plus 17 would be, sorry, that plus 7 would be 15. So our vertex is 2, 15. So we already have 2 of our critical points. And remember, once we've established the vertex, we know that the axis of symmetry is x equals 2. So the only thing we have left to do is find the zeros, and then we're going to graph it here at the bottom. Okay? So the zeros, remember that would be 0 equals, whoops, not too sure what happened there. -2x squared plus 8x plus 7. And you know what? I'm going to give you a little heads up here. I can tell by looking at this, but you know, I have only factor pair is 7 and 1, and the only factor pair of this, if I get rid of the negative, is 2 and 1. There's no way I can combine 7 and 1 with the 2 and 1 to make this 8 happen. This thing doesn't factor. And because it doesn't factor, I can just go straight to quadratic formula. Okay? -2, and I don't need to change that leading coefficient to a positive. So opposite b plus or minus square root b squared minus 4 times a times c all over 2 times a. Now, on that thing in the square root sign, 8 squared, and then 4 times 2 times 7 would be 56. And there's 2 negatives, so it'd be 8 squared plus 56. That comes out to 120. That is not a perfect square. We're going to have to use our calculator here. We're going to do 2 things. We're going to do this thing with the plus and with the minus. And we should come out to -0.74 and 4.74. All right. So we have to kind of guesstimate down there. -0.74 is going to be, about right there. 1, 2, 3, 4. There's almost 5. Remember, our vertex was not a bad number. It was a little bit high, 2, 15. So let me do my axis of symmetry. That's going to be on the 2. Whoops. My pen's not working right. Let's get rid of this thing. So there's my axis of symmetry. My y-intercept, which we found right away, that was 0, 1, 2, 3, 4, 5, 6, 7. Okay. And that's 8. So 9, 10, 11, 12, 13, 14, 15. You know, it looks like our vertex is about there. Now remember, sometimes it's easier to make the parabola if you find the mirror image to this y-intercept. You see how the y-intercept is 2 units away from the green? So we go 2 units the other direction. And there is my parabola. Okay? So remember, it's not always going to factor. You know, that's just the deal. That's the dealio. On the back side, whoops. So this one looks a little different. We actually did one like this the other day. This one, first of all, it's not written in standard form. I'm going to rewrite it. And you notice that there's no C term. So there's some things that make this one easier. But first, let's determine, you know, what we know. We know it opens up because the A value is +1. We know that the y-intercept, this is invisible 0 out here, so that's going to be 0, 0. So that's real easy. That's what we can determine right away. The vertex is where the work starts a little bit. X equals the opposite of B over 2 times A. Well, that's going to be -8. Now remember, we got to plug that in. So if I plug -8 into x squared, -8 squared is 64. And then I'm going to have -8 times 16. Well, that's going to be minus 128. 64 minus 128 is -64. So we got a vertex here that's way down there, of course. All right. Let's find the zeros. Now, I'm hoping that you're thinking, hey, this looks a little bit different. There's no C term. I can take out a GCF, which in this case is just x. So we get x equals 0, and we get x equals -16. That makes it really easy. Now, x equals 0 is right there. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16. We're just going to improvise here. Remember, my vertex was at the -8, 64. So that's going to be right here at the edge of the given part of the graph. But the vertex is going to be, let me extend that a little bit. It's going to be so far down. Okay, it's going to be way down. And what else do we know? We know that the y-intercept was 0, 0. That's the same thing as one of our solutions. So we actually only have 2 critical points that we can see. We have a third one, but it's so far down at -8, -64. So I'm just going to draw a parabola. But, you know, I'm just drawing part of it because, whoops, the vertex is just way down there. Okay? Sometimes you have to do that. There we go. There. Don't forget about GCF option. All right, next one. So this is a word problem. And here, take a look. We're going to talk about this, spend some time with this. Small company markets a new toy. The function S equals -64p squared plus 1600p predicts the number of sales in dollars. So capital S, that's the amount of money coming in. That's the revenue. That's the sales in dollars as a function of the price P in dollars. So what I want to do first is I just want to give you a little bit of an idea as to what we're talking about. When companies come up with a new product, they need to figure out how much to charge. Okay? They want to find that sweet spot. They want to make the most money possible, right? Now let me just give you let's say I came up with a new candy bar and it was pretty awesome. Peanut butter, chocolate, something to compete with Reese's. I just think it's the most, awesome candy bar in the world. And I decided, I'm going to charge $500 for each candy bar. If I tried to charge $500 for each candy bar, I wouldn't sell any. No one's going to buy a $500 candy bar. So my sales would be very small. Now, if I charge very little, okay, let's say I just charged a penny, I'm going to sell a ton of them. But I'm not going to get much money either because I'm just getting a penny each time. Okay. So, there's a sweet spot in there. I'm showing you some extremes. All right. So we're just going to sketch out a graph here. We're going to talk about price and we're going to talk about sales revenue. Okay. So just think about it. If this was zero, if my price was zero, I could give away whatever I made, right? And, I'm not going to get any money. But as I charge more money, my sales will go up. I'll get more money but then eventually I'm going to find, as I charge more and more for my product, people are eventually going to stop buying it. And if I charge too much, they're not going to buy any of it. So a lot of sales items follow this parabolic curve. Okay. For you to remember, this is the good stuff. This is sales revenue. You want to be as high as possible on this parabola. So you want to find a price that will allow you to get to this vertex, right? This peak up here. Because, if you charge too much, then you're selling down here, you're not moving much product. And even though you're charging a lot for it, you're not moving that much of it. So your overall sales are very small. Down here with the low price, you might sell a ton of product, but you're not getting a lot of money because you're charging such a low price. So there's an in-between sweet spot, and that's what we want to find. And I'm hoping you're thinking, hey, that sweet spot, the price that will give us the most sales, that would be the vertex, right? Anyway, let's start looking at the questions for this particular problem. So remember, S is sales, P is price. If the price is 6, how much in sales would they predict? Well, I hope that's easy. I just have to plug in, right? S would equal negative 64. Change the P with a 6. And we would just evaluate using our calculator what this would come out to. And this, remember, S is in dollars. So this would come out to 7,296 if we charged $6 per item. It doesn't for our new toy. We'd get $7,296 in sales revenue. But remember, we want to find, what price should we charge to sell the most? Okay. Here, the highest, what price will produce the highest sales total? Okay. Well, that means we want to find the vertex. We want to be the peak of that curve. Well, A was what? Negative 64, and B was 1600. C in this particular model was 0. So our X, in this case P, is going to be opposite B over 2 times A. And that comes out, again, using your calculator is handy, it comes out to $12.50. Now remember, that's the X value, that's the price of the vertex, and that's the answer for question B. We want to charge $12.50 per item. Remember, that's just part of the vertex though. You know, what does that give us? You know, here, let's look at part C. B and C really go together. These both involve just finding the vertex. So what is the maximum sales, total sales predicted? Now, of course, we just want to take that 1250 and plug it in. We're going to have to use our calculator to help us out here. And if you use your calculator, this comes out to exactly $10,000. And that's, you know, that's what you want in business typically, right? You want to maximize the revenue coming in. So if you charge a price of $12.50, you'll actually take in $10,000. Whereas if I charge a price of $6 in question A, I would maybe sell more toys, but the amount of revenue coming in would come down. You know, if the Xbox consoles dropped to $10, they'd sell a lot of Xbox consoles, a lot more. But it doesn't mean that they're making more money. Okay. Now here, think about this last one. If they wish to, this one's a little bit of work. If they wish to sell, whoops, we have to fix this. This should say, if they wish to sell $9,600 worth of toys, that's what it's supposed to say. What price should they charge? Okay. What price? So this means that we're given what? We want to sell $9,600 worth of toys. So we're given the S value. So that goes in for S, and we have to solve for P. Now that's going to involve more work. There's a B value, so I'm hoping you guys remember, hey, we have to set this equal to 0 because we have a B value. We would subtract 9,600. And you know, these numbers are so big. There is, let me grab a calculator here. Even if I took out a GCF, 64 does go into 9,600 and 1,600. But I still have these numbers that are kind of big. I mean, I think most of you would probably go to quadratic formula, which is fine, okay? So we would do x equals, I mean, we have big numbers here, I know, but opposite of b plus or minus square root, this is why we have calculators, b squared minus 4 times a times b all over 2 times a. Now let's, I really shouldn't write x here. We're really solving for p. So p is going to be what? This is negative 1,600 plus or minus square root. This is over negative 128. This number inside here is 102,400. Use your calculator. You're going to come up with two things. And they're both positive, actually. You're going to come up with p equals 10. Remember, this is the price. And p equals 15. Now, why do we get two values? So there's two different areas, two different ways where you could sell $9,600 worth of toys. Now, let me show you this. Okay. Let's go back to this parabola. Check this out. Let's just say that this up here equal with the vertex, that's going to be 10,000 because remember we found the peak was at 10,000. Well, 9,600 might be at this level. And you see how, let's say that that's the 9,600 level. And you see how it hits the parabola twice. So here, that would be like the $10. And then here, that would be the $15 price. So there's two different ways of getting to $9,600 in sales. Okay. You could price your items at $10. You could price them at $15. But, pretty much you're shooting for that sweet spot, looking for the vertex. All right. We're going to talk about this together during our lesson. See ya.